Now see in this example, calculate the radius of gyration of a cylindrical rod of mass m and length L about an axis of rotation perpendicular to its length and passing through its center. Suppose the rod is like this, whose mass is m and length is L, and it is rotating about this axis. So, moment of inertia I is equal to m L square by, here this we can add small m L square by 12. If k is suppose radius of gyration, so we can write I is equal to I dash is equal to m k square. So, m k square is equal to m L square by 12, this cancel. So, k is equal to L divided by square root of L square is L, and square root of 12 is, that is 2 root 3. So, this is the radius of gyration of the rod. Now, say in this example, there is a ladder of 3 meter long and its mass is 20 kg. It rests like this, one end is on the wall and another end is on the floor, and this end on the floor is 1 meter away from the wall. Now, we have to calculate in this case force F1, that is the force applied by the wall, and the force F2, the reaction at the point of contact here. So, F2 is the reaction by the ground here, which has got two components F and N. F is here the friction and N is here normal reaction. So, we can calculate is by using translational and rotational equilibrium. So, let us see. First, we take translational equilibrium along horizontal direction. So, here F1 is this side and F is this side. So, we can write F1 minus F is equal to 0, that is F1 is equal to F. So, this is the translational equilibrium along horizontal direction. We can also write N minus W is equal to 0, translational equilibrium along vertical direction. So, N is equal to W is equal to 20 into 9.8 is equal to 196 Newton. Now, we can take rotational equilibrium. So, total torque about the point A. So, there are the two torques due to the force F1 and due to W. So, we can write here the torque due to F1. So, F1 into, that is 2 root 2 minus W into, this is here from the distance is 1 by 2, that is equal to 0. This is the rotational equilibrium. So, we can write F1 2 root 2 is equal to W into 1 by 2, and then we can take here F1 is equal to W upon 4 root 2. So, we have calculated F1 and we have which is equal to F also here. So, F1 is equal to this much. Now, we have to calculate the total force F2. So, we can write here F2 is equal to under root of N square plus F square. So, value of F is this, that is here 196 divided by 4 root 2. So, by putting this value of F1 and by putting this value of N here, this is 196. When you solve it here, you will be getting F2 is equal to here 199.0 Newton. So, I have taken the value of F1 from here, that is here this one, and the value of N from here. So, in that case, this is F2 we have got. Now, we can calculate also here, that is the tan theta, this theta we can calculate. So, we can calculate tan theta. So, tan theta is equal to here in this case N by F. N by F means that is coming here 196 divided by, if you solve it you will be getting here 34.6 Newton. So, here 34.6 Newton, and that is equal to coming here 5.656. So, the tan theta is equal to 5.656. So, theta is equal to approximately here 80 degree. So, this is the theta and this is the F1 we have got this much, that is 34.6 Newton, and F2 we have got 199 here by putting the value of N and F from these equations. So, by using the rotational and translational equilibrium, you can solve the question here.